Welcome to Math 1324. This is section 2.3 on quadratic functions. Alright, so first off, let's start off easy. And the easiest of all quadratic functions is f of x is x squared. Now, that's important. One, that it's the easiest, and two, look at the exponent. The exponent has a squared. It won't have a cube or a fourth or a 5. The highest exponent is a 2. Now, f of x is x squared is a U-shaped parabola. This U-shaped parabola looks upward. It has a lowest point. That lowest point is called the vertex. Now you notice this lowest point is also the place of the x and y intercepts. They're all in exactly the same place. Now this quadratic function is symmetrical, and all quadratic functions are symmetrical about their axis of symmetry. And the axis of symmetry here is x equals 0. It goes right through the origin here where our vertex is. Now, in general, all quadratic functions are U-shaped parabolas, and these U-shaped parabolas either look downward or they look upward. So all quadratic functions must look like one of these two. Now, if it looks downward, the vertex is the highest point. It's the maximum place. And if the quadratic function looks upward, then the vertex is the lowest point, or the minimum. Now in this case, you see we have two x intercepts here, and they're on the x-axis. Here on the y-axis, you would have a y-intercept. Let's see, what else can we say about this. The axis of symmetry goes through the vertex, and it's going to cross at some point on the x-axis, and I've just called wherever that is h. So this axis of symmetry is the line x equals h. Now, how do you know if your quadratic function will look down or look up? Well, it's easy. Quadratic functions can come in two formats. F of x is ax squared plus bx plus c, or a times something squared plus or minus a number. If you focus on a, the thing in front of the squaring, if a is greater than 0, it looks up, and if a is less than 0, it looks down. So that'll tell you which one. Now, if we're talking about format number 1 here, that's the messiest, this format, because to find the vertex, I'm going to need to complete the square. Or I could also use what's called the Vertex Formula. And to find any x intercepts on the first form, I either have to be lucky to factor it or use the quadratic formula. In the second format here, to find the vertex, I can just read it as a shift. It's been moved left, right, up, or down. And to find the x-intercepts, I'm going to use the square root property. So in summary, quadratic functions are U-shaped and they look up or down, and the most important place is the vertex because it's either the highest or the lowest. Alright, so let's get into the homework here. Now, in question 1. They're going to give it to us in the most terrible format, and we're going to need to figure out, well, where is the vertex and how do I put it into the other format? All right, so let's see. We need to complete the square. So first off, look at this problem. I need to first group together the first two pieces. So I'm going to group this together. All right, so I've grouped it together. I'm leaving the -2 alone. Looking at this piece, I want to get the minus out of it. So let's see, -1 out, that means it's gone. But that changes the sign of that one to a -2. Now at that point, I want to look at just this inside piece. I want to complete the square on it. How did that go? I write down b is -2. I take b over 2, or 1/2 b. So let's see. -2 is b over 2 is -1. And I also need that number squared. So -1 squared is 1. So these are two key numbers I need. So to complete the square, I'm going to add this number in, right there. Add it in. But if I just add a number randomly in, I would have changed the problem. So I'm going to subtract it back out. Now you're thinking, wow, that's kind of stupid. I'm adding it in, subtracting it back out. What's the point? Well, the point is it's going to allow me to change how this thing looks. So now I'm going to keep together the first three. See right here? It's in the parentheses. This -1, I want to get it out of the parentheses. But it's being modified by this -1 in the front. So -1 times -1, if I want to get it out, is a +1. So at that point, we're getting there. So now let's see. -1 plus 1 minus 2 is a -1. This part in the inside factors. It factors by the number I saved for factoring. So x minus 1 squared. And so now we're in good shape. We now know exactly what has happened. You're thinking, wow, what has happened is a mess. Well, yes, it was. So let's see. First off, the a in the front is a -1, so it's flipped over. I can recognize now that we have a shift. The -1 means the parabola is flipped over, moved downward by 1, and this part was a shift left or right. Which way? Set it equal to 0. X minus 1 is 0, and I see x is 1, so it moved it to the right. So here's the deal. Normal x squared. We got it flipped over. We moved to the right by 1, so this part is 1 to the right, and then we moved it down by 1. And so that's what this quadratic function would look like. Don't panic, it's going to get easier. All right, so in question 2, they're going to ask us, well, we have f of x is x squared plus 8x plus 13. How does that look like x squared? Where did this thing get moved from the basic shape? Well, first off, look at the lead coefficient. It's positive. So it's not flipped over, so it's going to look upward. All right, so let's see. What's our plan of attack? So first off, like before, I keep together the first two. Now there's nothing I need to do here in terms of getting rid of a negative because there's not something in front of the x squared. So I go about the business of completing the square. B is 8. So right here, b is 8. b over 2, 8 over 2 is 4. I'm saving that for factoring. That's a plus 4. I square it. 4 squared is 16. And there's the little piece I've got for adding. Okay, so right here I've got the little piece for adding. So I add in the 16 and subtract it back out. I'm going to group together the first 3. All right. Now, I can get the minus 16 out of the parentheses because there's nothing modifying the front. Okay, so that's there. And so now minus 16 plus 13 is a minus 3. Factoring the inside, remember our plus 4, it's x plus 4 squared. So what do I see? I see 1, it's looking upward because a is 1, positive. We got shifted down by 3 because of the minus 3. This part, x plus 4 is 0, x is minus 4. So we moved left by 4, down by 3, making the vertex minus 4, minus 3. All right, so let's see, question 3. Oh, question 3 looks great because it's already in a great format. Lead coefficient is negative, so it's flipped over. I can see I can read off my shift. All right, so that part should be good. Let's see. Y-intercept. How do I get a y-intercept? Well, I set x to 0. G of x is y, so just plug it in. 0 plus 5 is 5. 5 squared is 25. But don't forget, there's this minus in the front. Minus 25 plus 7 is minus 18. All right, what about the x-intercepts? Well, I set y to 0. All right, so that looks like this. Now I'm going to solve it by the square root property. So I move this piece to the left, okay? I apply the square root property. I get rid of the squaring, plus or minus the square root of 7, okay? And now I'm going to move this plus 5 to the right. So here's my answers. My answers are minus 5 plus square root 7 and minus 5 minus square root 7. Now, would they be happy with that? No. What do they want? They want it either as an integer or a decimal rounded to 2 decimal places. So you take this, use your calculator, find the square root of 7, add a negative 5, and then round it to 2 decimal places. All right, where is the vertex? Let's see. Well, we got shifted up by 7. Okay, that's why the second number is 7. What about this part? This part is a shift left or right. Let's see, x plus 5 is 0, x is minus 5. Okay, so we got that. Does the function have a maximum or a minimum? Let's see. The negative means it is flipped over. That minus means flipped over. Therefore, we have a maximum. Now, where is the maximum? You start to panic. Well, where is it? Well, it's at the vertex. And the highest point is at 7. All right, what else? The range. Oh, let's see here. Alright, so here's my flipped over guy. Got moved over -5. So that's here at -5. Up by 7. Okay, so you see there is the highest. The highest value is 7. Here's my X and Y intercepts. The range. Well, the range, you see, never goes higher than 7. And then the parabola looks down forever. So that means that my range is -infinity up to and including the 7, which is y less than or equal to 7. The domain, well, the domain is easy. They didn't ask it to us. But the domain for all quadratic functions is the whole real number line. So we never have to worry about our inputs into these quadratic functions. All right, let's see. What about 4 here? Well, again, it's in a good format. Lead coefficient is positive. That means it looks up. And if it looks up, I'm going to be looking for a minimum. All right, I can read off that it got shifted down by 4, and this part is a left or right. But we're getting too far ahead. Where's our y-intercept? Set x to 0. 0 minus 4 squared. Well, a -4 squared is 16. 16 minus 4 is 12. X-intercepts. Again, this is in the format where I can use the square root property. Now you're looking at this and saying, why is he moving the 4? I thought last time we moved the squared. We did, and we moved it because it was negative. So move the negative piece to make it positive. All right, so by the square root property, this is easier. Square root of 4 is 2. So my answers are 4 plus or minus 2. 4 plus 2 is 6. 4 minus 2 is 2. So they are at 6 and 2. And we use a comma to separate the answers. Let's see my vertex. Well, we knew it was at -4. This part was a left or right. X minus 4 is 0. X is 4. And it's not flipped over, we said. All right, so let's see. Where's my rough sketch? Oh, here it is. It's looking up. Okay, there it is. My vertex was at 4 minus 4. So here's my vertex. Here's my two x-intercepts. Here's the y-intercept. My axis of symmetry goes down the middle of the vertex, and the middle was at 4. Let's see, the lowest it ever gets is -4, and it goes up forever. So my range is -4 up. So in terms of this way, we could have wrote it in an interval notation too. So either way, it will accept it. Y greater than or equal to -4, or in our interval notation. All right, question 5, back to the terrible form. All right, so let's see. I can say is a negative in the front, so it is flipped over, so it does look down. If it looks down, I'm going to be looking for the vertex, which is a maximum. All right, what about the y-intercept? All right, well, let's see the y-intercept. If I set x to 0, I get -29. But let's see, first off, they wanted it in the vertex form. Let's scroll down here. All right, so in the vertex form, let's see, what do we do again? I forget. Ah, yes, we grouped together the first two items, just like it is. Okay, got that there. left the number alone, and so now I'm going to pull this minus 2 out. So that's a minus 2 times an x squared plus a 8x, right? Because minus 2 times 8 is this minus 16. So again, I'm factoring a minus 2 out of the problem. Now, at that point, b is 8. So b over 2 is 8 over 2, which is 4. That was my factoring number. b over 2 squared is 4 squared, which is 16. So again, I'm adding and subtracting 16. The minus 29 is just sitting out here on the end. So now I want to keep together the first three. That's what's happened here. I want to get out this minus 16 out of the parentheses, but it's modified by this minus 2. Minus 2 times minus 16 is a plus 32. And when I combine it with the minus 29, I get a 3. This piece factors, where was my factoring number, as a 4. So it is x plus 4 squared. So now it is flipped. X plus 4 is 0. X is minus 4. So I've gone left by 4. So this is at minus 4 and up by 3. And that's where the vertex is. And that's the highest point because it's flipped over. So therefore, my range is going to be minus infinity, the lowest, up to a 3. And it's a bracket because it is included. Alright, so that's my form for the vertex form. Let's go back up here. Alright, so that's what we got there. Y-intercept, you can use either format to get that. We saw that. The X-intercepts, alright, for the X-intercepts, I need to solve. Now I can solve them either way. I could use the ugly form and use the quadratic formula, which seems torturous, or I could use this nice form and use the square root property. Let's do that. I'm going to move the negative part. Yep, did that. I divide by 3. And now in this case, I'm going to go ahead and make it into a decimal. Why? Well, because they wanted my answers in a decimal form. So I don't need to keep fractions. Alright, so that gives me x plus 4 is plus or minus the square root of 1.5. And so I now just need to calculate this. Minus 4 plus square root 1.5. And then round to 2 places. And the other one, I do the subtraction and get it. We already found the vertex where that was at. Highest point was 3, so it's y less than or equal to 3. Yes, pretty hard. There's a lot going on there. Take your time, practice, keep looking at what I did, looking at the video, and you will be able to get through this. All right, let's see. Question 6. We have a marketing research company. We sell memory chips. Okay, so here's my price function. The price that I charge based on how many. Here's my revenue, which is X, the number I make, times my price. Okay, and so let's see, what does that look like? Well, R of X is X times P of X. So take X, distribute it in, and I get minus 3x squared plus 85x. Okay, so let's see. What can I tell you about that? We want to figure out which one is the revenue function. Well, let's see. First off, because it's a negative, that means it's flipped over. Well, it can't be this one because that one's looking up. So it has to be either A or B. Now, without even doing anything, I can tell you it's A. Well, how can I tell you it's A? You say, that's too fast. Well, look at the values. Here are your X's for your revenue. Look at these X's. These X's are negative. How can I produce negative items? So therefore, I know it can't be B. So here's my graph. And so looking at that, I need to figure out, well, where is the maximum? Well, I can't exactly tell from the graph, but I can kind of see it's between 10 and 15, somewhere in here, and it's around 600 for the highest. All right, well, let's see. To complete the square, let's see, I need B is this ugly number. All right, so there it is. I need to find B over 2 or a half times B. In this case, I'm going to do a half times B simply because B is an ugly fraction. And I don't want to do any kind of complicated flipping. So I'm going to take a half times B. So I get minus 85 over 6. That's going to be my factoring number. I need to square it, and I get 7225 over 336. What a mess you're thinking. All right, so now I'm going to add and subtract that item. Now, I need to keep together the first three. All right, that's here where I factored it. And now I need to get this guy out. So let's see, it's modified by this minus 3. Well, a minus times a minus makes it a plus. 3 goes into 36 12 times. So what that tells me is I got shifted over this way, let's see, to 85 over 6. So my vertex is at 85 over 6 and 7225 over 12. That's actually where the vertex is located. Now, they wanted me to round this to 2 decimal places. And where is this number? All right, well, let's see. So looking at this number is 602.03. All right, so that's at that place is the maximum revenue. That was the X value. Now, where did this number come from? Well, that's the price we charge for the chip. Remember, we had a P of X, our price. What was my P of X? It's up here. 85 minus 3 over X. Okay. 85 minus 3 times X. And so, to find the price, we're going to put in 85 over 6. And so I get 85 minus 3 times 85 over 6. And so that's 85 minus 85 over, let's see, 85. The 3 goes into 6 2 times. Okay. And so we would get 85 minus 85 over 2. So it's essentially half of 85. So 44. Let's see. So we need a round to take this in half. So what? 42.5. But we can't have half of a chip that we're making, and so it says round to the nearest dollar, and therefore this would round up to 43. So not an easy section, but I know you're up for the challenge.